Here is the solutions to the second assignment, and I'm proud of you that you're choosing to do this. Hopefully it won't take too long. So you have y equals e to the x, you have y equals 1, and x equals 2. We're going to graph this. I'm going to say, what am I going to say? You need to do it first, right? Just copying my video, you're not getting stronger. You're stronger at copying, which is whatever. So try, press pause, and can you graph it? All right, did you try? So e to the x starts here at 0, 1. It's just a sketch. It curves up this way, and then it goes this way. There's an asymptote at y equals 0, but that's what it kind of looks like. And then y equals 1 is this line. And then x equals 2, as I try to stretch it here, x equals 2 is this line. And then you can see that this is that shaded area where you have the curve. They're going to meet up there. We need to know what that, we might need to know where that point is. But we know the x values. All right. So it says find the area of that region. Well, area is an integration question. It goes from 0 to 2. And it's top subtract bottom. So the top is the curve, e to the x. Subtract the bottom, which is the line, 1. So it doesn't go down to 0. So it's e to the x subtract 1. And that's it. So to actually find the area, I got to integrate it. So the integration of e to the x is e to the x. The integration of 1 is x. And I'm going to integrate from 0 to 2. I then plug in 2 and subtract and plug in 0. E to the 0 is 1. Take away 0, so it's just 1. So this is just e squared take away 3. Part B. Find the volume, another integration question, revolving around the x-axis. So if I'm taking this area around the x-axis, is there a space between this area and the x-axis? Yes. So there are two circles. So I have pi r squared subtract pi r squared. And we have a big radius and a little radius to set up. And the bounds stay the same. And then I'm going to go top subtract bottom. So the top subtract the bottom is e to the x subtract 0, which is just e to the x. And then the little radius, top subtract bottom, is 1 take away 0, which is 1. And then to actually find the volume, this is e to the 2x. I can keep pi in front. So the hook of, if I do this on the side, the hook would be 2, so it needs a 1/2 in front of it, and the 2 would go away. So it's 1/2 e to the 2x. The integration of 1 is x, and that goes from 0 to 2. Pi will stay in front. Plug in 2 first. So it's 1/2 e to the 4 minus 2. Take away. Plug in 0, and you have 1/2 take away 0. And you can leave the answer just like that. Part C says find the volume using square cross-sections. So the formula for a square is you take the base and square it. And we know the base is top subtract bottom. So we're going to integrate from 0 to 2. The top is the curve, subtract the bottom, and square it. Notice no pi, because we're not revolving, it's not a circle. But there's the setup. Now, I'm going to have to expand this. So I'm going to FOIL before I integrate. So that's e to the 2x, because you add the exponents, minus e to the x, minus e to the x, and a negative is positive 1. So I'm going to come back here, and I got e to the 2x minus 2e to the x plus 1, and now I can integrate it. That's not hard. You can do the algebra, and then you can integrate it. So again, the hook is 2, so it needs a 1/2. So it's 1/2 e to the 2x. Here, the hook is 1. So what it was over was, it's just going to be, there's really no hook there to worry about, so you just copy negative 2 e to the x. And then 1, the integration's x, and that goes from 0 to 2. You're going to plug in 2 to begin with, and then subtract, and it's 0. So I'm going to use parentheses here. So e to the 0 is 1, so it's just 1/2. Take away 2 plus 0, which I don't need. And I don't need to simplify it, though I do know, well, no, 2 subtract negative, that's a be 4.5, whatever. And you have the answer. Next, we're going to revolve again. So if I redraw the shape here, so I have y equals 1, we have 2, and we have this shape again. So you can see what you're doing. Now y equals 10, I don't really care where it is, but it's way above, right? And so it's an integration question. And again, there's a space between 10 and this shaded area. So there are 2 radii, a big radius and a small radius. So top subtract bottom would be 10 take away 1. That's 9. And then top subtract the small radius is top subtract the curve. So that's going to be 10 subtract e to the x. I'm going to simplify this because I still have to. And I'm going to expand this. So 10 minus e to the x. I'm going to multiply it out. That's 100. It's not as bad as you think. Negative 10 to the e to the x. And then if I multiply this together, it's positive e to the 2x because you add the exponents together. So this is what you end up having. I'm going to use parentheses here. It has 100 minus 20e to the x plus e to the 2x. And now I'm ready. Well, let me simplify just one more step to make it maybe just a little easier. 81 take away 100, that's negative 19. A negative and a negative makes it positive 20 e to the x. And a negative and a positive makes it negative e to the 2x. Now we're ready to integrate. So negative, now we're going to keep pi outside. So negative 19 will be negative 19x. We have no hook there, so it's just 20e to the x. Here we do have a hook of 2, so we need a 1/2 e to the 2x. And that's going from 0 to 2. And then the last step, we're not going to simplify it. We're going to plug in 2. Subtract, use parentheses, plug in 0, so that's 0. E to the 0 and e to the 0, so that's just 20 take away 1/2. Done. Great job. Now we're going to revolve that around y equals 1. I'm just going to use the same picture. If you revolve it around y equals 1, there's no space. That's exactly the line of revolution right where the boundary is. One circle. So it's pi, and then top subtract bottom, and that's it. So we actually did this for the square just with a pi in front. So if I look, where's the answer where I integrated? So I already did this one just with a pi in front. So the answer I got here, you just need a pi in front of that, and that would be the answer. And if you want to double check how we did it, we foiled and set it up. So it's the same. That would be a square. That would be pi r squared, right? So a square or a circle, that would be the difference in terms of the volume that it creates. Part F. No part F. Number 2. Now you have the equation y equals x plus 2 and 1 plus x squared. My mind, I, goes right away that the derivative of the bottom might match the top. We're going to talk about it when it gets there. So, first of all, what is the area from 1 to 3? So, what would happen if I had just a bit of a sketch here? So, if I plug in, and it starts at 1, so if I plug in 1, I get 3 over 2. That's 1.5. If I plug in 2, I get 4 over 5, which is a little lower. And if I plug in 3, I get 5 over 10, which is a half. So it is decreasing, right, in terms of what's happening. The power term on the bottom is more powerful, so it's going to get closer and closer to 0, the end behavior. But this is what I'm integrating. This is the shape right here. So it's good to have a visual of what's happening. So part A says, hey, find the area of that. Well, that's integrating from 1 to 3, and I'm going to integrate this. And now the question is, how would I integrate? So this is a classic example of separating it. So I'm going to go x over 1 plus x squared, and then 2 over 1 plus x squared. 1 is a logarithm, and 1 is arctangent. So oh, this says set up but don't integrate. For specify. Sketch a region and set up integrals. Make sure. Oh man, I've been like working too hard. Well, there it is. But if you did separate and did want to integrate it, this would be a logarithm and this would be arctangent. I bet you knew that. Part B, I'm not going to keep doing that. I'm sorry I did that. Revolve it around the x-axis. So again, we're going to go 1 to 3. There is no space from the curve to the x-axis. It's solid. It's one circle. So pi r squared, and it's top subtract bottom. That would be the curve subtract 0, and it's done. Part C, if it's revolved around -1, there's -1. There is a space, so we have two circles, a big radius and a small radius. So the big radius is the curve subtract -1. So that's x plus 2 over 1 plus x squared. When you subtract a negative, you're adding. And here it's 0 subtract -1, which is just 1. And there's the setup. Part D, now I'll switch papers. Again, we're going to integrate rectangular cross-section. No pi in front, 1 to 3. So a rectangle is base times height. So the base is just top subtract bottom. So the top subtract bottom, the curve subtract 0. So that's just x plus 2 over 1 plus x squared. You could go subtract 0, but that's not necessary. It just says the height is 2. So there's the base times the height, and there's the setup. All right. Number 3. Do you ever hate doing more work than what you had to do? Me too, believe it or not. Here we go. But you got to get over it, right? No time machine. Can't go back. Here we go. X equals y squared subtract 4y plus 3. All right, this one, well, let's figure it out, right? So if I factor it, I'm going to find intercepts that I care about to be able to graph it. So the y-intercepts are at +1 and +3. So I'm going to focus there to begin with. So +1 and +3, that's what it's going to do. And it's going to be a sideways parabola. I already get a sense of that. X plus 1 starts at 1 and goes up 1 and to the right 1. So we have a line right here, and then we have a curve. And the vertex is not essential, but this is the area that we're talking about. So when they talk about the area of this, we're going to have to change the way that looks. We're going to have to write down x equals, so subtract 1. It needs to be in terms of y for it to find the area. So the setup in terms of y, I need to know this y coordinate and that y coordinate. Well, I know the bottom y coordinate's 1. For the other one, I need to make it equal to each other. So I'm going to go y minus 1. And I'm going to make it equal to y squared subtract 4y plus 3. And I'm going to solve it. So I'm going to combine like terms. So I'm going to subtract 1. That's -5y. I'm going to add 1. And then I'm going to factor this. So that's -1 and -4. So when I solve it, that means the bounds are going to go 1 to 4. Perfect. Then I'm going to go right, subtract left. So on the right is a line, which is y minus 1. And on the left is the curve, which is y squared minus 4y plus 3. And instead of dx, it would be dy. And these are y values. Part B. We're going to revolve that around the line x equals 3. So 1, 2, 3, this line right here. So now our bounds, in terms of that, so our bounds are going to stay the same. It goes 1 to 4. And now I'm going to go, there's a space there. So that means that there are two radii, a big radius and a small radius. So the big radius, right subtract left, is going to be 3 subtract the curve. That's the big radius. Make sure you use parentheses when you subtract, so it subtracts everything. Then the small radius, right subtract left. And again, use parentheses as 3 subtract the line, which is y minus 1. So you have 3 subtract for the big one, 3 subtract for the small one, and that's it. We're just setting it up. Part C. Semicircle cross sections. So a semicircle is pi r squared divided by 2. The radius is top subtract bottom, but that's going to be the diameter when I do that. So the radius is actually top subtract bottom divided by 2. So I have pi r squared divided by 2. So I'm going to make life easy. Pi over 2, I'm just going to put it in front. It's 1 to 4. And then inside is going to be top. In this case, it's actually right subtract left. So let me write it properly. Right subtract left. So for this curve, right subtract left, that is y minus 1 subtract y squared minus 4y plus 3. And that's it. Oh, and then you have to do what to this? Divide it by 2 for the radius. So right subtract left is the diameter, divided by 2 for the radius, and then square. So now it's pi r squared divided by 2. Now it's semicircles. You can totally do it, right, if you just take your time and think through it. D, rectangular cross sections. No, what do we got? I just did it. No D. One left, number 4. We got this. Look, I'm going to get like 20 minutes, maybe 25. You got this. So I get to use a calculator. All right. So the reason you're going to need a calculator is for the points of intersection, because you're still just going to set it up. So to find the area here, I need to use a calculator and see where they cross. So that's what I'm going to do. So again, menu actions, and you can delete it with number 4, and then just start away. Here we go. So the first one is just x cubed. Again, I'm using this for the points of intersection so I know what my bounds are. So x cubed, subtract x plus 1. The second one, press tab again, is sine. And then type in the square root of, so that's kind of different, right? So the square root of x squared plus 1. And I see, and it says you use the bounded area that is completely in quadrant number 1. So just quadrant number 1. Let's change the window so you can see that. So in quadrant 1, there it is. Just that. See if that's a good picture. Let me do this again. Menu, window. We don't even need that much. So like 2. And we don't need, this can be 0. Oops. 2. Let's see if that gives a good picture. There it is. Okay, so you see that now, the red compared to, and the nice thing about this calculator, the red, you can see what the red is. It's sine. And the blue, you can see what that is. So it's awesome. First of all, I know top subtract bottom. Red on top, blue on the bottom. Perfect, right? Then we're going to go menu. We're going to go analyze and points of intersection. That's number 4. And we're going to move it to the left of where they intersect. Oops. Sometimes if your arrow goes below the screen, it gets stuck. So you got to make sure your hand is still on the screen, and then press down and press down again. And it's 0.155 or 56. And then the other bound, again, I'm going to go menu, analyze, intersection, number 4. So again, I'm going to move this to the left, press down, and then to the right and press down. It's going to highlight over it. It's going to give you the second answer, which is 0.993. So now you have your bounds. I don't need my calculator anymore because now I know top subtract bottom. So red is on top, the blue is on the bottom. So trig is on top. So that would be sine the square root of x squared plus 1 subtract, use parentheses, x squared, oh, just 1 second here, All right, x cubed minus x plus 1 dx. And there's the setup. Part B, find the volume around the x-axis. So you can see there's a space there, right, where the x-axis is at the very bottom. So that means there's two of them, same bounds. So pi r squared subtract pi r squared. So again, top subtract bottom. The red is on top. That's the trig. So the sine square root of x squared plus 1, subtract 0, I don't need. And then the bottom is going to be x cubed minus x plus 1, subtract 0, which I don't need, dx. All right, part C. Okay, same bounds. Rectangular cross sections. And so, again, we're going to go top subtract bottom for the base. And then it says the base is twice the base. So I could go times 2 and repeat it, or just square and times 2. So I can go times 2 and repeat all that, or just say, hey, it's times 2, and if it repeats, I just square that. I'd rather do that. All right, D, we're almost there. How about if you revolve it around y equals 2? Now, if you revolve it around y equals 2, that's going to be above. So when I go top subtract bottom, recognize what that's happening. So there is a space there. So it's 0.156 to 0.993. There are 2 again. And now when I go top subtract bottom, that 2 is on top. Subtract the bottom, which is the blue, which is x cubed minus x plus 1. And then when I go top subtract bottom, now it's the curve, which is sine and the square root of x squared plus 1. Last one. You're doing great. Revolve it around y equals negative 2. So negative 2 is on the bottom. So when I go top subtract bottom, it's the red subtract negative 2. So there's my setup. I set this up first, right? So now it's sine square root of x plus 1. And now I'm going to subtract negative 2. I know when I subtract negative 2, it really means adding. And I'm going to do the same thing for the next one. So the smaller radius is going to be x cubed minus x plus 1, subtract negative 2. And you did it. Mr. G Math over and out. I am proud of you for doing your second work for spring break. Till next time.